I'd like to welcome everyone to today's webinar. It's Product Management Tips for Data Science Projects. Today's webinar takes a look at some unique differences that data science projects present for product managers. Our speaker will help us understand these challenges and provide some tips for overcoming them. With that, I'd like to introduce our speaker for today, Rich Mironov. He's the CEO of Mironov Consulting. I've had the pleasure of moderating for Rich previously, and I'm sure you will enjoy this intriguing topic. Rich, over to you.
Great, thanks so much. Hoping everybody can hear me clearly, and we're seeing our title slide. Let me flip over to just a little more of a brief introduction for me, for those who may not know it. My handle's at the bottom if anybody has trouble finding me. I've been doing software product management mostly for enterprise, mostly in Silicon Valley since the 80s, so not a new thing. These days I spend most of my time coaching heads of product, mostly at software companies, and I also sometimes do what's called the smoke jumper job, where I drop into a Bay Area company as their head of product for a while to get some things straightened out. Some of you may know I've been blogging in the space since 2002, mostly because that's when blogs arrived. One couldn't really have been blogging before then. Had the chance to found the first product camp in 2008 and been very involved in the agile development movement since, you can see, roughly 2005. So again, not a new thing. Probably the most important thing on this list, and we'll touch it, I think, several times during the presentation, is I'm a much stronger advocate of outcomes versus processes. So I don't believe there's any magic framework or process that delivers universally great results. I don't see a perfect best practice that applies to every company for every situation. We need to apply good judgment. We need to use our learning and our history and our social networks and everything else to figure out how to fix or solve problems in the instance we're in, rather than adopting somebody else's perfect framework for their perfect situation. The focus for today is going to be on skills for product leaders, and here I'm generalizing product managers, product owners, anybody else who has the product title or product responsibility to build out things that are going to include data science teams. And I have about 5 points to make, shockingly enough for everybody. I'll tick them off here in order 1 through 5, and then we'll go through each in a little more detail. So first thing we'll touch on is that I observe that data science teams often have a lot less background in the company's business or the customers we serve or the market that we're in than our typical development teams, many of which have been on board for a long time. So as the product manager, product leader, I know I have to provide much more context and goals and information about use cases and background to my data science team than I might with some other folks on similar projects. Second thing we'll touch on is to remember to recognize that a lot of data science projects don't play out. There's uncertainty in whether any particular data set's going to be predictive or useful or economic. And so rather than decide that we're going to commit to a delivery date for something before we've done our research, our data science homework, we want to make sure we build in time in every project or every product release to see if the data science actually plays out before we promise a date. Third thing, identifying the right data sets is really critical. Often this isn't so much about is the data in existence, but do we have the right to use it? Are there privacy issues? Who owns it? What does it cost? Can we get access? So again, before we promise to deliver something that needs a data set that we may not have the rights to or the access to, let's make sure we're doing our homework way up front. Fourth one, and we'll dig into this in some detail, is the question of how accurate any particular application or model or data science solution has to be, which is all about the use case, not really about the data itself. So we'll have a bunch of examples thinking about some applications or use cases where it doesn't have to be particularly accurate, and other ones where accuracy is really very, very important. And thinking that through before we spend our $1 million or $5 million building something, because maybe we're going to get the wrong thing. And then lastly, I often run into data scientists, particularly folks who are recently out of academic programs, which is many, maybe most of them, who believe that done means they've built a model that has a good F-score or is somehow predictive in a pure science point of view. I'll tell us that if we haven't wired those systems or those decisions or those recommendations into real operational production systems, and we're using those to make real life decisions in the world, then it's just science in the lab. And so we have to think about how to move from it works on my machine and it has a good F-score to how do real people get to use the implications or results of that model or analysis or machine learning or whatever we're doing. So that's our 5 points. I'll take questions throughout as we go, but let's unpack these one at a time. All right, first thing, deep context. Here's our young person with a map. Again, I see that a lot of data science teams are new to the particular company they're working for. They may be new to the business setting entirely. They're probably not very familiar with our products or our financial drivers or what's really important to our users. They're often great data scientists, but they lack the specifics in our situation. And again, often they've been trained up to focus on the pure analysis part of the work and not on how we field applications out into the world. So an example here might be, because I work with a bunch of companies that are building software for the medical space or hospitals or healthcare. And it's likely that your newly hired or newly formed data science team doesn't know much about medical diagnosis, doesn't understand the economics of how hospitals work. So we might be recommending to do fewer tests, but some for-profit hospitals actually want to do more tests because that's how they bill insurance companies. You know, who makes decisions? The doctors, the systems people, the administrators. There's a lot of context that might be appropriate in, for instance, a medical diagnosis software product that I don't expect my team to know. So we're going to do some things for them. What are the how-tos? Clearly, as the product person who's working on this or part of the extended team, I want to walk through my data science team through use cases or anticipated use cases in some detail. How does it work? How do people think? What decisions do they make? In particular, what does success look like? Back to our hospital example, it might be saving on tests and overhead and doing less work. It might be on better patient outcomes. It might be on increased satisfaction among the doctors or nurses or other staff. Really unpacking and understanding what success looks like is critically important here, because otherwise we're going to measure and deliver the wrong thing. And I'm always looking for ways, and not just for my data science team, certainly for my designers and developers and everybody else, but I'm looking for ways to share really deep, direct context and input from clients and customers. If we're doing phone interviews, I either want to record those and play back the interesting portions for the team. Sometimes I'll invite folks to listen in on those calls in real time, probably on mute, as you guys are. They're going to be writing me notes on Post-its so that I get to ask questions I may have missed. But I find that hearing the real users and clients and customers talk about their problems both adds emotional value and context, and it means we're much more likely to build the right thing. Designers have been telling us this for decades. We don't just want a product person out there doing interviews. We probably want a product manager plus a senior designer and maybe an architect or a senior software person, because we all listen in with different ears to the same conversation. So again, just summing up the point, as the product person on some product or project, I really want to make sure that my data science team internalizes, feels the pain, understands where these customers are going, because we're much more likely to get good answers and good applications. Okay, take a deep breath. Go ahead.
Rich, I just came up with a question on
Sure.
my own here. Just from your experience, do you see that similar problems come from like SMEs who move into data science? Because I know that is also a common route.
Yeah, I see a sort of different failure mode with SMEs in general, which is that because they're subject matter experts and they spent a lot of time, or maybe not recently, but time in the field, they tend to value their own judgment and experience over what customers and research tell them, because they're smart, because they know, because they're the experts. And often that leads either to old assumptions about the market, which has moved, or ignoring a lot of good inputs because it doesn't really match what that subject expert believes is true. It's easy as an SME to override all of the other outside inputs and decide that I'm the smartest kid on the block. And in my experience, that just doesn't lead to good product.
Yeah, I've seen that as well. So providing this problem context would help in that case as well.
That's right. And if I'm worried about that, I'm going to find, again, it might be articles or research or interviews or a great thing if you're using one of the online user testing applications, usertesting.com or something. It's great to have a real user or a simulated user sit in front of your application and fail to be able to use it or find the buttons or locate help or get stuck because the commit button is below the fold on the browser. And having the team, both the engineering and design team and the data science folks, really watch somebody struggle, I think brings the emotional content home of not enough that the two smart folks on my team can use it in the lab, but our users are failing because it's too complicated or the workflow doesn't work or the recommendations are unclear, right? That it's not okay just for the product manager to communicate what's wrong. We really want to connect the team viscerally to what's really out there.
Yeah, that makes sense. Thanks.
Yeah, and I also see that teams work twice as hard when they've heard a real person out there describe what's not working so well. They'll work nights and weekends because they've attached a real person's voice or face to the issue at hand instead of just what some product person says. Okay, let's jump ahead to number 2. In case anybody's missing, there's 5 of these coming up, but there's some interleaved stuff. I observe, again, with a lot of bloody noses and bruises, that my judgment and a lot of other people's judgment about what's going to be predictive or work in the data science space is pretty weak. We all think that something's going to be obvious and it's not. So, magical thinking, the hoped for correlations, dirty data, different departments don't use the same field names, or maybe they use the same field names for different content, right? It's really easy, if you're not the data scientist, to jump to some conclusions about how easy it's going to be, right? And so we'll have some examples in a moment, but the to-dos here, the first one is, and I got this from one of my clients who's a data scientist, he said he really prefers when the product folks or the people framing up the problem put it in terms of a clear hypothesis. I think this data set will help predict that kind of outcome. And when we do that, we're giving a leg up, as you can see in the picture, to our data science team because now they know what we're talking about, right? And we want to set aside time at the very beginning of a project or product release, get the data, try the validations, see if it's going to play out, find out if it's useful, run the numbers. Because often, maybe even the majority of the time, we find that our intuition's pretty poor here, and the data just doesn't tell us as much as we would like to know, which also means we should be thinking about secondary data sources, alternate places to get information. Be thinking about what we're going to do if this particular hypothesis doesn't play out. In fact, I think I have a few examples here. One that's not yet on the next slide, so I'll jump in, but there's been a lot of interesting science over the years where folks have correlated, those of you who go to supermarkets that have discount cards that let the supermarkets and therefore the consumer goods firms behind them figure out what you buy and in what bundles and in what combinations and frequencies. There's some good data science that shows us that there's a high correlation between folks who go to the supermarket and buy small sizes of disposable diapers and beer. And we're not 100% sure why that is, but it may be that some of the dads are staying home and need some comfort out of all this. But it's also not clear what we learned from that. And so just because something's correlated doesn't mean it's going to tell us very much. So let's dig into a couple of examples here. The first one, I did some work at Yahoo maybe a decade or more ago and was able to see a little bit of what the movie reviews team was doing there. And there's this theory that we could go onto one of the movie review sites, Rotten Tomatoes or such, and look at the movie scores, the reviews, and figure out which movies are going to make money. And that should be easy, and everybody's good sense around data science is this is obvious. Some facts get in the way. One of them is it turns out that almost everybody who goes onto a movie review site assigns that movie either a 1-star, 4-star, or 5-star rating. And that's because the folks who thought it was a 2 or a 3-star movie don't bother to review it. And so the data that we're getting on those sites is heavily skewed toward folks who actively disliked it enough that they wanted to post a review that was really horrible, or loved it enough that they want to give it the 4 or 5 stars. And so we've got a small, skewed, non-representative audience, and it's pretty hard to extract good analysis and good forecasts from that. I think the evidence here is that the movie studios, have spent tremendous amounts of money trying to figure out which movies are going to make and which movies are not going to make break even on this. And they continue to be surprised at which things are the breakout hits. You may find that Netflix has much, much better data than the studios do, because they actually know every time I pause or restart or finish or don't finish a movie or a TV show, but still pretty hard to predict. One that I think is even more clear, there's a lot of folks who have the impression that if we go back and look at a few decades worth of corporate earnings reports, we'll be able to figure out which stocks are going to go up next week or next year or next month. Again, our intuition here is going to fail us. A lot of financial quant firms are spending huge sums of money trying to figure out how to get out ahead of the stock market. There are, as far as I know, no documented successes here. But of course, if somebody were getting this to work, they probably wouldn't tell us. They just continue to earn those hundreds of millions. But the outside indicators are that they're going to be much, much more successful trying to do the sort of very high frequency programmatic trading in the fractions of milliseconds to try to get ahead of the market's digestion of news as it's posted, rather than trying to go back and look at historical things that are years or decades old. Again, the point to make here is, as a non-data scientist, I may have a lot of expectations. I'm sure that this data set's going to really help us. Well, not so much, right? So we want to plan the time to do the research before we sign up and tell our CEOs that we're going to ship a bunch of updates to do this. Okay, let's roll ahead. Let's look at number 3.
Hey,
I'm
Rich,
sorry, go ahead, Mike.
Before you go into 3, when we first reviewed this material a couple days ago, I had this idea that confirmation bias might be part of the issue you're talking about, but also now that I listened to it in full, I don't know if that's true or not. So can you talk about that?
Sure. I think confirmation bias, particularly when we're doing either small groups of qualitative interviews, and then it's easy to listen in and decide what we heard was more positive than what the folks told us. I see a lot of confirmation bias coming from senior executives on the team. Sometimes we call that the, there's a bunch of other bias names for that, like the hippo bias or the leadership bias, where they tell us that this data is really going to be predictive. And then, there's a lot of confirmation bias where we forget to set a test goal before we start the work. So classically, if we haven't figured out what accuracy we need or how good is good before we run the data, we're always going to decide that it was good enough, that 60% was good enough or 72% was good enough, because we really want it to be true. So as a product person, I want to maintain a lot of objectivity. There's honestly nothing worse than working on a product for 2 or 3 years that doesn't work and doesn't pay out. So as a product person, I want to be vigilant about my own biases, my recency bias, my, the whole stack of Daniel Kahneman biases here, where I'm going to convince myself it's going to work no matter what the data says.
Yeah, got it. Thanks.
Okay, good, great. Let's keep rolling. Let's talk about choosing or accessing data sets. This will seem obvious, but a lot of people forget. My intentions don't matter. My intuition doesn't matter. If we don't get a data set that actually predicts what I needed to predict and delivers it in a way we can operationalize, it doesn't work, right? So failure is thinking it's going to be good, and then going ahead without that. Often we've got a lot of choices for choosing different data sources that behave differently. We'll have some examples coming up here, but we might find that public surveys have different kinds of biases than actual buying behavior, if that's what we're looking at, maybe in an e-commerce setting. And sometimes we're looking at our own data sets. We end up deciding that they're not as clean, that they're dirtier or incomplete, and that we need to go out and buy some data. So the earlier we start to figure out how to get access and make sure we're allowed to use them, the sooner we'll actually be able to run some tests on it. So what do we do? Of course, here's the things to do, right? I think we want to plan before we choose one particular data set to think about the choices and maybe run experiments on a few and get the best one. Sometimes we'll find that combining a few different data sets gives us more predictability than any one of them together. And then again, putting my narrower product management hat on, I really want to be asking questions about getting access. Do we need to pay for it? Do we need licenses? Do we need NDAs? Are there privacy concerns? Are we going to get in trouble with GDPR if we use any data from European users, right? There's a lot of gritty, ugly, how do we get it, are we allowed to do it kinds of issues, which if we skip, we're going to get to the end and be rather disappointed because it's going to turn out that we can't afford it, or it's not accessible, or there's usage guidelines on it. We just didn't think about it. Commercial terms, maybe the people selling us or renting us this data want tremendous amounts of money, and it's just not worth it for us to spend it on that. And we might give up the project because the benefits of the project are smaller than the combination of buying the data and running my data science team through it. So let's think about this and get started on the product side early, rather than getting to the end and finding out we're just not allowed. Okay, great. Let's dig into one that I think is a little harder. If we're thinking about accuracy, and we're going to find that our data science friends actually have a bunch of different terms for accuracy. I've gone sort of generalist and non-technical here, but we're going to ask questions, and they're going to ask questions of us about how predictive it has to be or how accurate it has to be, depending on the use case. And I'm going to say this a bunch of times, but it's really important. We may have different uses for the same set of data that have different accuracy requirements, and we'll put up a couple of examples. And that's really important because before we start down this road, we really want to know what success looks like. If 80% is good enough, we may have it within a week. If it has to be 99.65%, it may take months, or we may never get there. And then the last part of this that I think may be less obvious is certainly every machine language or AI or natural language processing scenario will have false negatives and false positives. Some people like to talk about type 1 and type 2 errors. We're always going to be making some mistakes, and so we need to think really deeply about what the costs or implications of those mistakes are. Again, we'll have some examples in a sec, so that we're doing the right thing. So let's talk about what we're going to do before we drag out a few examples. Think about use cases and goals and the cost of errors, again, before we sign up for a delivery date. If people are going to die when we get this wrong, then we better have really, really high accuracy in mind. We want to talk about that performance and metrics and goals and accuracy with our data science team before we start doing the analysis. And comes back to Mike's point, I think, about various kinds of bias here. The team's going to come back and say, oh, this is 85% predictable or predictive. And if I haven't decided whether 85% is good enough or not, I'll always say yes, because there's lots of pressure to move ahead with these things. And then, of course, and again, we're going to unpack this in a sec, we need a plan as product folks, as data scientists, as vendors of software, as users of this stuff, to decide what to do when we get what either is or appears to be a wrong answer. By the way, sometimes it'll be the right answer that's less obvious. What do we do? So what's our plan before we get all ahead of steam here? So let's put up a couple of examples here, because I think this is better done in the specifics than in the general. So two examples. One, I've done work with a bunch of work with an East Coast company that's very involved in e-commerce and shipping and delivery and predicting how long it's going to take for packages to arrive. And one of the big discussions is, can we put together a better routing algorithm for the trucks we're going to send out into major cities and urban environments so we can plan their routes out better and have fewer stops. Clearly, the goal here is to save some time, save some fuel, get the trucks back with less wear and tear. But honestly, the cost of misrouting a truck as it drives around a city is relatively pretty small. If we can find some reasonable savings in time, that's great. If not, we move on. So we might decide that for this particular application, which is going to use lots of geotagging and addresses and trucking models about how fast they can move through the city, we only need to maybe be 80% right. If we can be even 20% better than the human dispatchers, which may have maps on their walls and are drawing this out with black Sharpies, that's good enough, because the cost of being a little late delivering the package honestly isn't so serious, right? So we're going to have a low level of expectation here, and good enough is probably good enough. Let's give a strong counterexample. Let's imagine that we have some machine analysis. We got a bunch of machine learning that's going to look at water quality reports and identify water samples that either have excessive levels of lead and other metals and heavy metals in them, or dangerous bacteria, or for some reason we're going to have this machine help us decide if this drinking water is safe to drink. Well, every system's going to have errors. I would really want to slant our system toward fewer false negatives here. If we sample a pipette full of water here and we tell the world that it's okay and people drink it and die, that's a pretty bad outcome. Whereas if we raised a bunch more suspicions because we were going to turn all of the suspicious samples over to humans to retest, the cost of a false positive is pretty low. So again, notice we're mixing both accuracy and the false positive, false negative question here. We really need to think about what the real world implications are of getting this application wrong or having our accuracy wrong. Again, hospital things, if you think about anything that's going to detect incoming satellites that we're worried might be armed, right? We probably don't want to launch that nuclear war on a false positive. Thanks. Good. Anyway, so really important that we think about accuracy and predictive value in our specific use case, not in general. Okay, let me take a pause in case there's any questions on that, because I have one other related thing to dig into. No. Okay, good. So the last part of this is every machine learning system, every natural language processing system, every data science driven thing is going to have some errors. It just is. So let's look at an example here, another real world example. A lot of banks are trying to apply machine learning to the approval process for mortgages, right? And it seems pretty clear that those banks can speed up that mortgage application review process maybe 20 times, certainly huge, and save lots of time and money and maybe reduce their risk and reduce the staff that has to read these things. But, right, as we know, some of these decisions are going to be odd, a little wonky on the side. So things to worry about. We've been reading a lot lately about training data that includes biases, historical biases, right, or illegal inferences. In the mortgage space, what we might discover is that 50 years worth of redlining, where banks were not making mortgages to certain parts of town where there were poor folks or minorities, or for some other reason they had drawn a red line around that part of town. Our 50 years worth of data is going to, in fact, reinforce that bias. And we may unknowingly be creating inferences which are wrong or reflect old economic conditions. We may have new mortgage products that don't work the same. I was talking to somebody yesterday on a related thing who pointed out that if we use as our data set all of the people who've ever been elected as president of the United States, we might notice that no woman can ever be a president of the United States. Well, maybe, maybe not, but some clear bias in the data as we go forward into the next election season. right? Good. Some other things that we might be watching for, right? We might have training data that's wrongly tagged, in which case we're learning the wrong thing. In every case, I think we as product folks and we as responsible builders of applications need to have a plan. Are we going to have a human review of complaints as they come in? If somebody's rejected for a mortgage and they believe they're clearly qualified, we should probably put that in some stack where real people who really understand mortgages review that application and decide if the system's making a mistake. Even if it's not making a mistake, we may be required to explain what happened in ways that machine learning systems are pretty bad at explaining. So it's not good enough to say, we didn't like you and the machine rejected your application for reasons we don't understand. We're going to be forced to have some better explanations from that. And then lastly, we know that every model gets old. The data's old, the product's changed, the laws changed, there may be some regional issues here, all kinds of reasons. So we need a plan to go back perhaps every quarter or two, re-inspect, reapply. We might pull 20 or 30 or 100 mortgages out of the system at random, have experts grade those and see if we're still on track. Because we know we're going to have mistakes and often we fail to have a plan or to think about how we as humans and corporate citizens are going to deal with those. Okay, I'll take a breath here. Okay, out of the 5, here's our 5th one, and this one's one I've been spending a lot of time on. I'm doing some work with a Bay Area AI company, and we've spent a lot of time thinking about operationalizing the work. So let me frame the problem up for us to be clear, which is, again, we often find that folks new to the corporate space who've come out of more academic data science programs, they're trained to stop once their model works, right? It works on my machine. It's got a good F-score. It's predictive. It's more predictive than the person at the chair next to me. I got a good grade on my project. And there's almost never much time spent in how we're going to plug that into the business's own systems or processes or outreach or interfaces, right? Because it turns out that if you don't share those insights and results with anybody, they don't matter. A good example here that I've run into a few times is you might be at an e-commerce company, and again, back to shipping just because I've spent a lot of time on that problem, and we're going to improve the algorithm that estimates how long it's going to take to deliver something that you're currently looking at on the screen, right? We might be selling some consumer goods, and if we can show you that that sweater is going to get delivered to you 2 days earlier in time for your Thanksgiving dinner, because everybody was supposed to get an ugly holiday sweater for that event, you might buy it, whereas if it's predicted to take 4 or 5 days, you might skip. If we haven't figured out how to wire that data into a display that appears to our end consumers, then it's never going to have an impact on any business that we do. It's fine that we knew in the back room that something was faster, but how do we make those insights visible to users, visible to consumers, visible to folks in our organizations who make decisions? Okay, so what do? This may seem obvious. I'm always trying to organize discussions both with my data science team and my engineering team, which owns the systems these are going to get plugged into, early. Do we need APIs? Do we need real time? Where will this stuff live? How will we move answers from place to place? What do we do when it comes up with nothing, right? And we want to talk those through at a sort of systems and architecture level really early, because if there's no way to plug this model or this insight into what we're doing, it's going to be of very little value. So let's talk about a few examples here. I actually have a different one I want to walk through in some detail. So here's, again, an e-commerce example where we're going to create a brand new machine learning system that looks at purchases that are happening overseas and tries to decide if they're fraudulent transactions. Right? There's purchase history, there's size of thing, there's how many people in the basket, there's countries they're coming from, all kinds of data we might throw into this problem of figuring out whether a particular payment is fraudulent, in which case we're going to be out a bunch of money and we would rather not close the sale. Okay, but how do we operationalize it? First thing that comes up, and we talked some about false negatives, false positives. If I reject too many transactions, my e-commerce company loses money because we have all kinds of folks who want to buy our dog food or sweaters or electronic gear, whatever it is. And if we're rejecting too many of them because we accidentally think they're fraudulent, top line effect, less money, more inventory, we miss our goals, right? So how do we think about that? We need to think about timing. In this instance, I'm assuming some consumer is looking at a screen, looking at a browser, and they're going to hit the buy or not buy button. And so we have to get a real-time assessment about how long it's going to take to ship this item, or I'm sorry, how long it's going to take to decide if this is fraudulent or not, something on the order of 150 milliseconds. If we can't get an answer back in that amount of time, they will hit the buy button, and it's too late. So in this instance, speed of computing is going to be a really big issue, and we may have a lot of argument between the core systems folks and the data scientists about how long it takes to run through a model, or can we stage it, or can we, pre-process a lot of stuff. Other things we might do. We might have some existing systems that already do fraud signaling, and we have to decide if this is an addition to that or a replacement to that. And if we're going to add this new signal into an existing workflow, let's think about all of the problems of taking one more new input and wiring it into some existing financial system that's got all kinds of issues, right? Where is it hosted? Is it on the wrong platform, et cetera, et cetera. And then finally, we might have a bunch of national or regional differences. If we have subsidiaries around the world, they may want to be making different decisions about purchases from their home countries or regions. There may be different laws involved. So again, these are all operational challenges in this one case around fraud alerts for machine learning, where it's not enough just to have a model that's predictive. We're going to have a lot of ugly, interesting, exciting challenges wiring this thing into our overall business so we can use it to get some good answers. Okay, I'm going to do a quick recap of our 5 takeaways. For anybody who missed it, that to the right is a takeaway container, right? So just to recap before we get to some of the SynerZip content and Q&A, right? As a product person embarking on a data science project with a bunch of really smart data scientists, I need to provide lots of context because I usually assume they don't know as much about the company, the customers, the market as I do. We want to have some hypotheses. We want to say, if X predicts Y, I want to do it, and check that out before we sign up for a delivery date. Spend some cycles, make sure we can get the data we want, that it's accessible, that it's allowable, that it's legal. Think a lot here about accuracy or model performance before we get into all of our selection bias about wanting it to be true. And then how are we going to wire it in so either our customers or our employees can get the results out of the system rather than having it sit on some data scientist's desk somewhere, right? And all of those, I think, are the ways we end up building much stronger partnerships between whatever business unit or product team wants this thing to work and the data science team that's excited to deliver it. Because when we work together, when we think about the problems, when we respect each other and appreciate our strengths and shortcomings, we get way better answers than when we just rush ahead and assume something's going to work. Okay, here's how to find me for anybody who didn't know. I bought my domain name in 1992 before most of the folks in the former Soviet Union were on the internet, so I get to have my name as my handle. But there's 18 years worth of blog posts up here if anybody wants to troll through those. They're all free, lots of presentations, and we'll hope to put this SynerZip recording up there as soon as it's available as well. Okay, let me take a breath and give this over to Mike, because I think Mike wants to tell us a little bit.
Yes, thanks, Rich. So at this point, I'd like to encourage everyone to enter your questions into the chat box. I'm going to give you a couple of minutes to do that, and while you're doing that, I'm just going to briefly go over what Synerzip does for your benefit. So Synerzip is an agile software partner. Our model is to help people accelerate their roadmaps by providing professionals on various different models. We're able to address technology skill gaps. We have a wide variety of skills at our disposal. We have about 450 to 500 engineers and QA people ready to go. We also provide UI and UX and product management. And primarily we do this sourced out of India, which allows great savings on if you were to hire these people locally. Next slide, please, Rich. Synerzip's been around for 15 years. We just had a glorious 15-year celebration in Pune, India. I happened to get to attend last week. It was quite nice. We have a wide variety of customers. Here's a list for you. Generally, all of our customers are referenceable, and we really appreciate their business. Next slide, please. So next week, our next of the series of webinars will be role of the API manager. I doubt it is click to edit master title style. That seems like some sort of a mission there.
Sorry.
No, I think that's on our part. That'll be Thursday, December 12th, also at noon Central Time. It should be a good topic. I have done this type of role in the past myself and always wondered this question as I was doing it.
I'm excited. I hope to join in on that. I think it's going to be really, really interesting.
Yes. Okay, next slide, please. Yeah, so that's it for us. So I will look to questions.
All right, and while we're doing that, I'm going to back us up to our takeaway points in case anybody wants to reference any of those or come back to those.
All right, so we got a few questions. I'm just going through them real quick. So here's a question from the audience. How can we validate the hypothesis in advance? It says because to do the validation, you have to spend time to build the models, of course.
I think that's right. So there's probably two kinds of validation here. So one is the model kind of validation, and you know, ideally the data science team can take a short measured amount of time, you know, you'd like to say a week or less, and run the models through and see if they can get good predictive scores out of it, right? That's a chance to look at the data, find out what's missing, see how dirty it is, really get a quick dig into what's going on before we commit. The other thing, and it's really a product management issue, is we want to do validation in the market with real users, real customers, real prospects to make sure the thing we're going to build is useful. I often tell people that the biggest waste we can possibly have in the world is to build an application that's on time, on budget, beautiful, has a great UI, and no one wants to use it, right? So that's a product failure, not an engineering or data science failure, but we really want to make sure that the thing we're going to do is both predictive, which is data science validation, and useful, which is market product validation. Otherwise, let's not bother.
Great, thanks for that, Rich. The next question is, how do you basically sell data science solutions to potential buyers? Is there a special technique that you found useful?
Are we thinking internal within a company or to customers, to outsiders?
I'm assuming customers. Based
okay.
On the question.
I was in Australia last month to MC a couple of product conferences, and there was a really smart woman named Sally Foote, who out of London runs a company called Photobox that does, you know, you upload your photos and you can create photo books out of them that they print. And she had a really good talk on how customers are not interested in AI or data science or machine learning. And her point was, if your application works better, that's good. If it delivers more value to users, that's good. But on average, folks on the other side of the glass screen, I think, are pretty uninterested in how we got there, unless it looks like a mistake. So I would probably not be selling anything about data science to end consumers. If I'm in a B2B setting where this is going to make my application or value higher, then I might engage my B2B customers to walk them through it because there'll be both benefits and issues there. But I find that it's the results that matter, not as much the tools we're using, because if our tools don't work, we should change our tools. And if they give us good results, folks are often not interested in how we got there.
Great, thanks. The next question is more on the internal side, but it's really how do you maybe combat leadership bias? If someone's coming in with an aggressive belief and you don't think that you can achieve that, how do you sort of push back on that?
This is really hard. So before I throw out any suggestions, let me just reiterate. Telling your senior executives that their idea isn't so good sometimes is a short trip to cleaning up your CV and working somewhere else. I usually try to get really analytical about this and depersonalize it as much as I can. Sometimes we go for the process step where I might say, that seems like a really good idea. I love that idea. Historically, what we found is that a lot of our good ideas play out well and some of them don't. So our very first step is going to be to do some homework on this. We're going to pull in our data team for a few days and take a look at it. We're going to do some quick market validation. We're going to find a way to test whether this is both valuable and predictive. And I want to have that discussion in a way that doesn't criticize the executives or call them dumb. Sometimes that works, sometimes it doesn't. I almost always have a list in my pocket of previous projects or data science things that weren't as predictive as we liked, because it's much easier to go back in history and say, look, here's 2 or 3 or 6 projects that we were pretty sure would work out, and 4 of them didn't. And so before we go commit to a ship date and spend, $1 million or $5 million on this, I really want to make sure that we do some homework and do the validation. The benefit to the executives is we want to avoid spending that $1 million with nothing to show for it, and we'd like to get a quick read back within a week or two if that's the right amount of time. The other thing that usually comes up is, and I don't know about anybody who's listening, but I've never found a data science team that had time on their hands. Right? There's always a backlog of work to do. So rather than saying, yes, let's jump on that, I always want to bring out the backlog and see what we're currently working on, both in a validation sense and in a final production sense, because we're going to have to push something aside. And I observe that very few people, especially executives who come to me wanting something, ever remember that the team is more than fully busy and that we're going to have to slow down or cancel something else to do this. And when presented with a list of things that are currently being worked on, we don't even have to call it a roadmap, just here's what's underway, a lot of folks will back off and agree that this can go into the validation queue for later because they're remembering the reasons why the number one thing we're working on is what we're working on. So it shows respect to the executives if we don't assume that they remember all the stuff we're working on because they're busy and they have other stressors, and to start with a recap of what's currently underway, because those are likely to be much more important than whatever new item from shiny object from today is.
Yeah, that makes sense. So here's another question. How would you essentially document the accuracy requirements? Is there a story format that you use or some other recommendation?
I don't know. I mean, so different teams want it different ways. I think it's probably a one-liner that says, needs to match our training data more than 96.5% of the time, right? Different data science teams will have different terminology. They may even have some formats. They're smarter than I am about this. So, I take my lead. I want to satisfy myself and them that we're doing this in the right way. I don't care what format it is. It makes no difference to me. So whatever the team is comfortable with, we use. If we don't have one, I'll start with a one-liner that goes into whatever user story or epic or ticket or tracking system we're using.
Okay, thanks for that. I'm going to interject a question because I'm curious. So do you find that a lot of the data science project ideas come from looking at the data first, or do they usually come from some hypothesis and then let's go find some data? Because you talked about gathering data, the price of data and all that. Just wondering what you've seen in your experience.
I see good ideas come from everywhere. The ones that come from the users tend to be really good ideas, but usually badly supported once we see the data. And so those are hypothetically good, but rarely pan out. I sometimes see the data team itself noticing things that we may use. That's heavily dependent, again, back to context. If they really understand our business, then the insights that they may discover looking at the data themselves are often valuable. But there's a lot of correlation or even predictability that is so obvious to the business that the data scientists didn't know was obvious, right? So back to the mortgage one, you might be surprised to find out that mortgages that are in zip codes that are much more affluent neighborhoods have lower default rates than mortgages in zip codes that are less affluent. And if you didn't know much about the mortgage business or owning houses, you might be shocked and surprised and run into my office to tell me you've discovered this new correlation. And I'd sort of roll my eyes and shake my head and say, yeah, everybody knows this. That's what the banking business is about, right? So, there's a lot of good ideas in a lot of places. I don't see a shortage of ideas. I see a shortage of ideas that validate. And so, we have to be all of us be really humble that most of those good ideas just don't play out. And so we have to have a big backlog of ones we're really ready to move to next.
So on a related note, someone asked is there a way to determine what good assumptions are before you start a project exercise? Is it obvious? Is there a rating system? How would you go about that?
I don't know of any universal way to rate this stuff or to size it. I mean, we're all bringing good judgment and experience to the pie, to the party. No idea, right? So I think there's good theoretical frameworks to decide if something is predictive in the pure data sense. I don't have any magic answers for how to say whether it's useful or if it's a good hypothesis. The test we might apply, though, is let's assume that hypothesis is true, that it plays out. What would we do differently in our company or with our customers or in our application? What would we do differently, and what's that worth? So if we can cut down the gasoline consumption and truck time of our trucks, is that a $5,000 opportunity per week, a $50,000 opportunity per week, or a $5 million opportunity per week? Because if it's a $5,000 opportunity, we probably can't ever pay off just the salaries of the data team to go figure it out, right? So I'm usually looking for both a lightweight business case. That's a one-liner from the product side that says, if we could better predict sweater shipping times on our sweater e-commerce site, we think there's $50 million in there, or nothing, right? And then on the data side, we apply our best analytics to that. But I think you need both of those, and I don't have any magic.
Yeah, that's still a helpful answer. Thank you. So with that, I think we're done with questions. There were a couple of pretty technical questions that came in, Rich, but I'm guessing that you're probably not going to want to dive into that detail. So I apologize to those who asked those technical questions.
That's okay. I aren't a data scientist.
Yeah, so with that, we've reached the end of time. I want to thank everyone for joining, for the good questions that you asked, and I especially want to thank Rich for taking his time to talk to all of us. Thank you very much.
Great. Have a great day.